Hey there, friends. It's Bill McDonald, the math doctor with Common Sense Math. Common Sense Math with Dr. Bill, whichever way you prefer to say it. And I'm going to be sharing a quick third grade question with you today. And it has to do with measurement, not with customary units, but with metric units. And I'm noticing that whenever we ask kids to go from customary units of measure, things that they're accustomed to or used to, and switch over to things that are from the metric system that we're not used to using in the United States. It's almost as if we're talking in a different language. And so, one thing that I did with my students to help them understand uh, was that whenever you're doing conversions from one unit to another, it's sort of like learning a different language. And so, what I want to do with you on today's question is not only help you solve one based on metric units of liquid measurement, but I also want to share with you a customary comparison that you can write down with your students that they can keep track of. Because I always feel like if I can see one, then I'll remember how it relates to other things. And so I'm going to call it basically translating across units of measure. So it's cross converting. Um, But just so that you can relate to what I'm sharing with, I printed out this little uh, page that I have in my one of my math PowerPoints. And so I want you to notice I intentionally made it appear that I was writing in some foreign language and that your typical student who struggles with reading, even though they're reading English, what you're seeing there in front of them is hard to understand. And so, whether you're listening to someone you don't understand and you start to stop paying attention after a while, or whether you're looking at something that you don't understand and you stop paying attention, it's going to be the same thing. So, even though as adults we have been exposed to enough customary and metric types of measurement where we can relate, many students can't. So before I get into the lesson and how to convert across conversions so that we can understand a little better, let me try to read this to you. We walled a co-os igi Ojo, Joe Offix Zipcell. Their total bill came to $24.98. So all I understood was that somebody paid for something that cost them that amount. Geoff gave the waffle a $50 bill. Okay. I don't know who Geoff is, but it sounds like a person. A waffle sounds like something you eat, but in this case, somebody who received the money. How much change will he Hoftheft? Well, all I understood was the keywords dollars, dollars, and how much change. The only numbers I understood were $24.98. Okay. Cents and dollars. Conversions and change, you typically subtract. So when I take that over here to the third grade question, our third grade page 5 of the third grade math surgery. This is our question number 3, and the question similar to it was number 6 on the third grade test. And again, even though we use metric quite a bit in the US, your students aren't familiar with it. So I would suggest that before you give them a question like this, go to pages 22 and 24 of the math posters so that we can see, okay, with capacity, let's see how they measure units using milliliters and liters. And again, the key component is understanding one. An eyedropper is about 1 milliliter. A graduated cylinder, it's going to graduate to, so the point when it's full, it would have in this one up to 50. So a little skinny one, again with liquid. This one here, it has the capacity for more than 100, but you can only measure up to 100 milliliters. Perfume bottles can be very tiny, from 1 milliliter up to 100 milliliters, very expensive. Uh, and that's one of the reasons they probably sell them in such small bottles, because you're basically paying for a brand instead of necessarily quality. I can probably buy the same scent at the Dollar Tree that somebody would have to pay hundreds of dollars for in a fancy store. Typically, water bottles come in little liter containers. Okay? Soda bottles can come in tiny 1 liter bottles like that one, 2 liters, and 3 liter bottles. Engine oil is up to 5 liters. Okay? When you do the comparison, an ounce, an eye drop, you might use ounces, but you see eyedropper, a milliliter. So you just gotta see which way that they're measuring the liquid. And you can look on the container, are they measuring in standard units that we'll call volume, or are they using capacity? All right, typical things: a gallon, 1 quart, 1 pint, and 1 cup/8 ounces. That has to do with milk. The 2 milks that your students will see the most are a gallon of milk at their house and a cup or 8 ounces in the cafeteria. These ice chests that they often sell at stores are 5 gallons, or these jugs of water for people who live in areas where the water is not really safe to drink, would also be 5 gallons, but they do have the 3 gallon size that maybe goes up to about here. The average bathtub might hold about 50 gallons. A propane tank, maybe 500 gallons. And an above ground pool like this size, maybe 1,300 gallons. Okay. So the next thing that I think would help was something that I did with my students when I'm um, trying to go across back and forth from capacity with custom uh, to volume. I wanted my students to be able to know, if I know one in customary, what was its similar cross conversion using volume. So when I looked it up, a little over a gallon a gallon of milk, a gallon of orange juice, liquid, is about 4 liters. 1 gallon. So not necessarily 4 quarts, because you can see it doesn't come out right exact. Okay? But you can infer, since 4 quarts makes a gallon, a liter is pretty similar to a quart in terms of uh, how much liquid that we're talking about. 1 ounce is 30 milliliters. A tablespoon, what you often use to take medicine, is about 15 milliliters, and 1 teaspoon is 5 milliliters. All right. So I would suggest, since I don't have anything where those are cross-referenced like that, but I would suggest that you teach your students do that. The question that I have here is, Jorge is buying 5 liters of liquid. And so then right away, I would remember that, oh, it was the engine oil. That large container of engine oil could be sold in 5 liters. And then if you look here, it 4 liters, the closest one that I have in the cross conversions, is about a gallon. And so if you see that, your students might think of a gallon of engine oil, right? So which of the following is he most likely going to purchase? Well, a 5 liter bottle of perfume. Well, no, because we said a uh, perfume is going to be from 1 to 100 milliliters. And again, if you let your kids see these, the visual learners will be able to hopefully memorize these. And as I did with other units, what you see here filled out on one page is empty on the next page, so your students can plug them in after they've kind of memorized each one of these. We have a 5 liter bottle of water to drink. Well, typically, uh, you're not going to uh, buy 5 liters of water. They typically sell liters, as we mentioned, in 1 liter bottles. They're just small sizes. So I would typically think I wouldn't need 5 liters for a bottle of water. I would only need one. A 5 liter bottle of soda. Well, it's close, but we remember when we saw the picture that most sodas are sold in 1, 2, and 3 liter bottles, and it's closer to a gallon that we would buy something in 5 liters. So a 5 liter container of engine oil for a car, so close to a gallon of water, a gallon of engine oil. Don't want to put water in your engine, that would kill it. Okay. Um, so 1 gallon or 5 liters of oil would be the best. And so I think, like I mentioned, if you can get them to be able to translate from one language that's simple, what is one of these compared to however many a similar amount of the metric side would be in liters or milliliters. I think that might help your kids be able to remember, because a picture paints 1,000 words, and I only need one picture of each of these: a gallon, an ounce, a tablespoon, and a teaspoon, to be able to cross-reference or to do a cross conversion for some of these here. So when you have your kids look at these, I would suggest that if your kids don't have a hard copy of the posters that are in the back of your binder, at least let them have a digital copy that they can have access to in their computers so they can have a quick reference. I had a teacher tell me one time, she attended my training and said, "Man, Bill, I really love your strategies and your materials, and they're all so amazing, but I'm not going to be able to use them." And I was like, "Why?" And she was like, "Well, I can't use them on the test." And I was a little bit confused because I was like, "This is the beginning of the year." So I said, This is August. You need to be a teacher for a while." A lot of times students need tools to help them. They need pictures. And what I've done intentionally for you guys, because I felt like there just wasn't enough materials out there in terms of measurement. And you can see based on the results of only 28% of the kids in Texas understanding uh, the concept of capacity with liters and milliliters and what amounts made sense. Uh, Hopefully, having these on your wall or at least in your students' math binders or portfolios will help them remember things for longer amounts. And then the idea of the conversions translating from customary, a language they're familiar with, to the metric system, the language, as you can tell from the results of that question, that they're not familiar with. So take care, and we will see you on the next video.